Hello everyone, welcome back to the channel. Today we are diving into the world of the real-time monitoring systems. Monitoring is critical for maintaining the performance, reliability, and health of your servers and services. In this video, we will explore how to design a real-time monitoring system that scales, it is reliable, and it can help identify issues before they become major problems. So let's get started. So, in your system design interview, and your interviewer asks you about to design a real-time monitoring system. So, first things first, we need to understand what is a monitoring system. And a real-time monitoring system is the backbone of a healthy infrastructure. Imagine managing a fleet of 10,000 servers, monitoring CPU usage, memory, disk utilization, and application logs all in real time without an efficient monitoring system. Understanding and troubleshooting issues would be really nearly impossible. Okay, so monitoring we use it to understand what's going on in the system on high level. So, and in today's video, we'll design a system that continuously monitors metrics like CPU usage, memory, disk usage, and server logs, alerts users as well of potential issues, and provides insights through a comprehensive dashboard. Um, so when you are in a system design interview, first we need to understand what actually we're designing and what is this application is all about. The second thing, we need to gather all the requirements that we needed. And third, we need to have some estimations. So first, let's start with the requirement. First, let's start with the function requirement. First, we have to have like a continuous monitoring collectors. I didn't put it here. We have to add a multi-source monitoring, support multiple metric forms. We need achieving old, also archiving old metrics. We need to have a powerful query. We need to alert mechanism for notifications, and we need a real time for the dashboard. In the non-function requirement, we need first scalability, supports about 10,000 servers initially with annual growth of 20%. Reliability as well and durability. The system should be reliable to collect the data and set alert. We ensure the system is high available to like ensure 24/7 uptime to guarantee continuous monitoring and low latency. We need to provide real-time or near real-time processing and visualization. Sorry, my pronunciation is not that good. Okay. Um, let's talk about some estimations that help us to understand what are going to design basically. So first, we have a scale estimation. Um, each metrics is collected every 10 seconds, and each server has 6 metrics. With 10,000 servers, this means we have a total of 6,000 write requests per second. Assuming each metric is 100 bytes, the monthly storage requirement is estimated to be around 88 terabyte. Assuming notification size is 1 kilobyte, we will need about 50 gigabyte for user data and 250 gigabyte. Okay, so let's start in designing the system. Oh, this is the old system. What is? Oh, this is the notification system. Let's go beyond here. Okay, let's start here. And let's first add. Let's make it white, and we will add like a server. And let's make it. And I want to make this white. Okay. Let's say that we have server 1 and server 2. And let's assume that each server has an agent, and we will talk about that. So we will have each server will have an agent. Server agent, it's like a lightweight agent installed on each server to collect metrics and logs. Okay, so let's put this one here. We'll have like an agent. We call an agent. Um, agent, and I guess I put agent. Yeah, agent is right. Is right like that. And each one have an agent. Sorry, guys, I'm quite ill this time. So we have server one and server two, and each one has an agent. And we said that server agents are lightweight agents installed on each server to collect metrics and logs. And next, we should have our real-time monitoring system service. So I put big one here. Okay, and I needed to make it uh, first the color, and I also want to make it like that. Mm. No, let's make it this. I guess there's a way to change the pa. Ah, okay, okay, this is good. So this is, let's put the text here. Oh no, let's make it way more smaller. This will be the real time monitoring system, and we will make it way more smaller and put here. Okay, and I want to change its color and make it green. Okay, so first, the server agents will send requests here. No, no, no. Let's go in. Go in through. No, okay. It doesn't want to do it. Add another one here. Let's make it small and make it like that. And I don't want to make it. It will be like a message queue. Like let's say MQ, message queue. Let's call it. And can I make this? Yeah. Um, no, let's give it different color here. And yeah, everything will be in different color right now. Okay, this is way more better. So the agent will try to send the request. It will come through the message queue. Okay. And it will send data. It will go through the message queue. And first, we have what we call data integration system, like tools like Apache Kafka and RabbitMQ to ingest and manage data streams. We could use this in the message queue. And then we have, should the message queue send the request to a streaming processor system, like we could use Apache Flink or Apache Storm to process the data in real time and evaluate alert conditions. So let's just put this up there, and it will be send requests to a streaming processing process one C streaming processing pipeline. Okay, and this streaming processing pipeline will send will save the request or save these things into databases. First, we have a time series database like stored, processed, data in a time series database like DB or timescale DB. And also we have a relational database that will store our data in it as well. So let's put this because monitoring is all about time. Let's put it like that. And we can add this is a time DB. As well, the time DB, like it's a processed metrics are stored in the time DB database. It's like, as we said, in flux dbx or time scale. They are ideal for this use case because they are optimized for storing and querying timestamp data. This allows us to visualize both real-time and historical metrics with minimal latency. We should also have our own DB for alerting and stuff. No, delete. Let's say that we have a relational database or DBMS or a DBMS. Okay. Mm. We should then have alerting. The DB should be connected with an alerting. Let's add um let's give it an E. Okay, I didn't expect it to. Okay, let's give it a different shape because this one is not doing it. Which shape should we get? Okay, let's get this one. And let's give the alerting different color as well so we understand what's going on here. It will be better. Okay, this as well. This is looking good right now. Also, all of that will be should be with send to our own dashboard. Let's call it dash because we said that we need to send everything to a dash board. And let's make this wider and give it different color. Let's make it white. Okay. Okay, so we have the dashboard. Also, the real time should be send request to the dashboard. And we should as well have like a batch pipeline. Let's add another one here. This should be like a batch pipeline. And this batch pipeline, let's make this. This batch pipeline should store data in a long-term storage. And it should send all the data here. Okay, let me just try to understand and try to look at what's going on in details. Okay, so first things first. Let's go back to the server agent. Okay, let's just put this as again here. No, no, no. Back. Okay, like that. This is will be better. First, we have the monitoring agents, and they are installed on each server to collect data like CPU usage, memory usage, disk usage, and logs. These agents must be lightweight to ensure they do not impact server's performance significantly. And the metrics are collected at regular intervals, like every 10 seconds, and are forwarded to central monitoring service. And the logs are collected and transmitted when changes are detected, ensuring all critical data is captured. Okay. Um, the second thing we have the data in ingestion system, which is the message queue, will be like we use Kafka or something like that. So the data ingestion system acts as a buffer between our agent and the streaming systems. We can use Apache Kafka or RabbitMQ. They can handle a high throughput of incoming data from thousands of servers and providing fault tolerance. The second thing, we have Kafka. Kafka basically helps distribute data effectively and efficiently, ensuring that even if there is a peak activity, the system can continue to process incoming metrics without any issue. Then we have the streaming processing. We can use it like a Flink or a Storm. The streaming processing system processes the ingested data in real time using tools like Apache Flink or Apache Storm. We can evaluate conditions like CPU or memory thresholds and identify anomalies. For example, this component allows us to apply user-defined alert rules and also transforming raw metrics into actionable insights. For instance, if CPU usage exceeded a threshold, the processing system will trigger an alert, which is then forwarded to notification service, for example. And we have a time series database. The time series database, like we are processed metrics are stored in a time series databases like InfluxDB or TimescaleDB. They aren't ideal for this use case because they are optimized for storing and querying timestamp data. This allows us to visualize both real-time and historical metrics with minimal latency. And also we have an alerting notification system, and this is the alerting system. When an alert condition is met, an alert notification system ensures the relevant users are notified immediately. A notification can be sent via message or push notification or whatever it will be. We can integrate like Twilio or PagerDuty, helps us to deliver alerts effectively. Um, and also we have like a user dashboard. We can use like Kibana. Finally, user dashboard provides a visibility into server health tools like Kibana can be used to create real-time dashboards that show CPU utilization, memory, and disk space and logs. The dashboards help users define alerts, rules, view historical data, and understand trends. The visual representation makes it easier to spot patterns, for example, sudden spikes in memory usage or consistent high utilization. We can talk about how the pull and the push is working, like how we push the metrics and how we pull the metrics. Um, so the pull method, the server agents push data to the monitoring system. This is suitable for real-time monitoring and because it ensures that data is delivered as soon as it collected. And the pull method, on the other hand, the monitoring system pulls the data from the agents. This provides better control from for monitoring services, but it is not ideal for real-time needs. And in our architecture, we will use push method to ensure real-time data delivered and support high-frequency metric collection. We could talk about the data storage. Yeah, we can talk about the data storage. We have like a server data table. Yeah, sorry, I didn't talk about the RDMs. The RDMs, or the relational database, will have like the alerts table. It will be have alerts table like alert ID, server ID, and the rule ID, and what is the status. And we might add in it like rules table, and we might add like a servers table. We might add this in the relational database. We can use like a SQL database, like SQL or Postgres, for example. Um, I guess this is a good design as a starting point design. We have some challenges that we need to that need to address. First, the scalability. As a server fleet grows, the monitoring system must scale too. And by using tools like Kafka and Flink, we ensure horizontal scalability by adding more nodes to handle increased load. The second thing is high availability. Like, since we are monitoring critical infrastructure, the system must be available 24/7 using redundant components and replicated databases. We can achieve minimal downtime. And third, we have low latency. Basically, alerts must be generated within 1 minute, detecting the issue. The use of real-time stream processing and high throughput ingestion systems ensure that data is processed and alerts are triggered without a delay. And we have data durability. Logs and metrics must be stored reliably, even during system failure. We can use a replication in TSDB, uh, and backup storage like AWS S3. We guarantee data durability. So, in conclusion, real-time monitoring is a key part of maintaining the reliability and health of any large-scale system. By combining data collection, real-time processing, alerting, and visualization, we can build a comprehensive monitoring solution that helps detect and respond to issues before they become critical. If you found this video helpful, make sure to like it, subscribe, and hit the notification bell so you'll never miss a video. And I hope this video will help you to ace your system design interview.